to mx plus or minus square root of a square m square plus b square. It is the normal to this one. This is normal means minus 2 comma 0. It should be. So this can be written as y minus x. Minus 2 is equal to square root of minus of root over a square plus b square. Because minus means you need to take this one. A square plus b square is equal to 2. So AB means a square plus b square by 2, or a square plus b square is always greater than equal to 2 root AB. So this value is equal to 2. 1 cancel. So AB. Oh, answer is not given. What is the answer they have given? Yes, Sai Charat.
Hello, sir. The value of a square plus b square should be 4, no, sir? You didn't square, sir. You squared only on the right hand side, sir.
Oh, okay. So 4. Yeah. A square plus b square 4. So answer should be 2, right?
Yes, sir.
What is given answer? 1 minute, I'll check this answer here only. This is 68th. Key sheet is this one.
Correct only, sir.
68. Yeah, this is sometime. 4 correct only, no? That's right answer only. Okay. Next question. Yes, Vignesh.
70.
70. What is the answer is given? What is the 70?
I got 3, sir. They gave 1, I think.
Yeah, you got say 3 means okay. They gave 1. You got this one.
Yeah, sir.
Yes, Sunat?
You will get option 1 only, sir.
1 only. So you got the wrong number. Okay. Yes, Siddharth. So when the
Sir, 1 only, sir, answer.
okay. Next question. Yeah, next one.
81.
81. Have you checked again from your side one more round? Okay.
Yeah, sir. Yes, sir.
Okay, 81. What is the answer you got and what is this?
Lambda belongs to open 0, comma 2, sir. And minus 1 extracted from that.
What is the answer you got?
Lambda belongs to 0, comma 2, minus 1.
The representative, the number of integral values of lambda.
Yes, sir.
What is this one? You can write it as x minus 1 by 5 whole square plus y minus 1 by 5 whole square. 5 square is there. So it is lambda square minus 2 lambda plus 1. That 5 will be coming this side. It is 3x plus 4y minus 1 by 5 whole square. So this value should lies between 0 and 1. So lambda minus 1 whole square lies between 0 and 1.
Sir, 0 and 2, no, sir.
Why 2? What is the eccentricity? No, here lambda minus 1 is this one. So here lambda is equal to what will happen? Lambda is not equal to 1. Minus
Yes, sir. Yeah.
lambda minus 1 is less than plus 1. So 0 is less than lambda less than 2. But
2.
lambda is not equal to 1.
Equal to 1. I got same, sir.
So what is the value? How many integral values are there between?
0 and 2.
Is it including? No.
Yes, sir.
No. If you give 0 is equal to 1, lambda is equal to 0, this is the parabola becomes, right?
Oh, okay, sir. I didn't check. That's why I got that, and I think 0 and 2 are the answers. I kept 2, sir.
No, that's equality is not there. That's very important. Okay,
So 2 is not also included, no, sir.
not included. So 0 to 2,
Okay, sir.
all the values except the integer value 1. So there won't be any.
Okay. Okay, sir.
Okay. Okay. And I'll try to keep this paper thing later. No, I do a recording. I'll try to record and I'll try to keep it that one. Okay. Yes. Advance. What is that? This model Saturday we have done. When the 2 points on this one is given, oh, it's as a foci is given and tangent. So there is no problem. Okay. Because when you do these distances now, that is 2AE will come. And when you find a perpendiculation from these points to this one, B square will come. From there, A square also comes. So directly you can do. Triangle formed by that any tangent and coordinate axis, you can write directly. Cannot be less than. So x by a plus x by a cos theta plus y by b sin theta is equal to 1. So area will be equal to half AB sin theta cos theta. So apply the AM greater than GM cases. The normal to the curve intersects the curve again at theta. Then what is the theta point? Okay. So somebody suggesting me to record and upload in the YouTube and giving that. I don't have any YouTube channels or anything. Okay. Yeah. If any record is there, I'll try to send directly to all the to the principal and from that. Okay. And 40th question is, if the curve obtains angle at the point, then the possible value of, yeah, curve is subtends obtuse angle. What is meant by subtends obtuse angle means here this curve is there, here this point is there. Okay, so this is obtuse angle. So angle between pair of tangents. So you write the tangent equation and go for M1, M2 from that point. Okay. Yes, there are the people raised that. Satish and Raghava.
Sir, can you explain 39th question, sir?
Okay. And yeah, 39th question. If the normal to the curve at the point intersects the curve again, so the curve equation is given as x square plus 3y square is equal to 4. So the equation is x square by 4 plus y square by 4 by 3 is equal to 1. Normal at pi by 6. What is the normal equation? Ax by cos theta minus by sin theta is equal to a square minus b square. So this is equal to x minus y is equal to 8 by 3 into root 3 by 4 is equal to 2 root 3. This value. Meeting the curve again at 2 cos theta 2 by root 3 sin theta. So 2 cos theta minus 2 by root 3 sin theta is equal to 2 root 3. So this is equal to root 3 cos theta minus sin theta is equal to 3 by 2 by 2 by 2. Okay. So what are the options are there? Just a minute. What are the options? Where is a question? So if the normal to this one meet at the point intersects again at the curve, then what is eccentric angle of theta? Yes. So here what is happening? You can write cos of theta plus pi by 6. Do we made any simplification mistake? Just check it out. The point is a cos theta, a sin theta only, right? Just look at the equation simplification because you are not getting the equation. No, here means the value. Yes, Sunat.
X minus y is equal to 2 by root 3.
Sorry.
X minus y is equal to 2 by root 3. 2 root 3.
Oh, right. That's correct. That's right. Yeah, root 3 is there, no? So here 2 by root 3. Thank you. 2 by root 3. So here 2 cancel. So in this step, what you're getting is root 3 cos theta minus sin theta is equal to 1 by 2 by 2 by 2. Cos of theta plus pi by 6 is equal to cos of pi by 3. So theta is equal to pi by 6, which is one correct answer. But you need to require, because this is the point that's satisfying. So one more thing you require. Theta plus pi by 6 is equal to, look at what are the options are there accordingly. We got it as cos of theta plus pi by 6 is equal to 1 by 3 pi by 2. Cos 3 pi by 2. Yes, you can take this one. 0, no. Pi by 2 minus will come, no. Pi, no. So this is the answer. Okay. Right. So as per the material, all the subtopics covered. Okay. So there is a diameter. One thing is that I'll explain that one quickly. And then I'll start explaining the hyperbola. Okay. Is it okay to you people? Or do I need to do today and tomorrow also ellipse? Because I want to cover it the ellipse in this week so that the last 3 days we can look at all the miscellaneous questions. Okay. Satish. Your voice, your voice. Your voice. Check the mic properly. Sai Charat.
Hello, sir. At
Hello,
that
sir.
last,
Hello, sir.
Tell me.
It's okay, sir.
Yeah, one after one. Yeah, you speak, Satish.
Sir, no, it is okay, sir.
No.
Hello, sir.
Yeah, tell me.
No, it's okay, sir.
Not that okay, some extent. Okay, no problem. You tell me what is the point.
Sir, this week syllabus also same ellipse.
Hyperbola up to except asymptotes. Except the asymptotes, everything will be there. Okay.
Okay, sir.
Sir,
Thank you, sir.
we need the 2 days practice of integral calculus. No, that's we'll see later, Nana. Now syllabus is very tight, is going on. Okay.
Hello, sir.
Yes, sir. Sai Charat.
No, sir, please explain multi-conceptual questions, sir.
Multi-conceptual. Once I complete the hyperbola, that's why if I complete these 3 days, this week hyperbola, no, Monday, Tuesday, Wednesday, we can look at all the things together: ellipse, hyperbola, parabola, everything together.
Okay, sir.
Okay. And did you teach common tangent? Nana, common tangents, it's not a special chapter, Nana. If there is a one ellipse, one parabola is there. What is the common tangent? If I want to talk about the common tangent, I will go with like this. Write the tangent to this ellipse. It should be a tangent to the parabola. Or if there is a circle and ellipse is like this. So here only these are the common tangent. If the ellipse is like this, circle is inscribed, common tangent will be this one. If the ellipse is like this, circle is this one. We discussed one question on the last class. What is this one? If the circle and ellipse are intersecting, r square should lies between a square and b square. So this is the common tangent. What we will do? Y is equal to mx plus e is a tangent to the ellipse, tangent to the circle. We'll take that one. Okay, so it's not only that one. So we are going to get the questions like this. What is that one? Locus of midpoints of chord of ellipse which touches a circle, attaches hyperbola or a normal to the parabola. So what happened? Locus of midpoint. So let the midpoint as x1, y1, ellipse. So chord equation S1 is equal to S11. You get the line. Apply whatever the condition is given. So this type of we can do. Okay. These questions. Okay. Right. So only my intention is to start the hyperbola is weekdays will be enough. Okay. And what is the thing? No, Monday, Tuesday, Wednesday, 3 days we are going to get in the coming week. So all together, any things are there missing out or looking at the commonly, we can look at that one. And Wednesday, okay, Thursday, next Thursday onwards, we are moving to the what you call complex numbers. Okay, right? So can you start hyperbola 2 days recap of the circles? Recap of the circles. Circles and parabola. See, one thing, what when I'm teaching the hyperbola, it's a recap for all the things. You need to assume only standard form is different. So except that one, everything in the similar lines. So you need not worry much about that. Okay, right. Yes. So I'll be starting the hyperbola. Okay. So what is the hyperbola? So again, the order is same. So what we will do? We will do the standard form. Then different types of hyperbola. Because here types, okay. Then parametric form. So again, parametric form, if I want to go for, I want the auxiliary circle. So auxiliary circle will be given. So I'll give the definition also even without knowing, giving the tangent equation. And fourth point is notations. Fifth point is what we will be giving is fifth point is chord, tangent, there itself normal. Next, chord of contact, midpoint. Because in this chapter, one special thing is there. That's rectangular hyperbola and the asymptotes. So except this asymptotes, everything is there for this week's syllabus. Except asymptotes, everything is there for the this week syllabus. Okay? Right. So let me start this one. Hyperbola. What is the hyperbola? S is the focus and L is equal to 0 is the directrix. Then locus of P such that SP by PM is equal to E. Here eccentricity E should be greater than 1 is hyperbola. Is hyperbola. So here what I'll do is, this is a fixed point S. This is a fixed line L. Okay. Maybe I change the color of the line. This is there. So the locus of point P, which is closer to the ellipse, than the focus. So you take P, this is PM, this is SP. So now this is in the plane geometry, nothing is there. So what we will do is, first I'll draw a line perpendicular to the directrix through the focus. That is the first step. Then take 2 points A comma A prime on this one. So first step. These steps are very common to ellipse, parabola, hyperbola. In parabola, equidistant means only 1 point will come. Ellipse and hyperbola, 2 points will take. Draw a line perpendicular to directrix through focus. Second one is, assume this point is Z. Second point is, let A comma A prime be 2 points on this line such that SA by AZ is equal to SA prime by A prime Z is equal to E. Means what I am assuming by default, I am saying this A and A prime are the points on the given hyperbola, whatever the hyperbola we are going to get. Now the third step is, let C be the midpoint. C be the midpoint of AA prime, and CA is equal to CA prime. CA is equal CA prime is equal to A units. In the next step, what we will do? So you will be getting this midpoint C is here. Draw a line parallel to the directrix through the center. Okay. And take it as y-axis, take it as x-axis. Automatically, this will be 0, 0. This point A will be A, 0. And this is minus A, 0. Everything comes at a time. So you write. Draw a line parallel to y-axis, no, not y-axis, what you call directrix. Parallel to directrix through C and consider as y-axis and AA dash as x-axis. So automatically what happens? C will be 0, 0. A will be A, 0. A prime will be minus A, 0. These are all we have done already. So now you take SA is equal to E into AZ. SA prime is equal to E into A prime Z. So SA plus SA prime is equal to SA plus SA prime is equal to E into AZ plus A prime Z. So this is SA plus. So this is what you are going to get is 2A is equal to E times of AZ. AZ can be written as CA minus CZ, and A prime Z is A prime C plus CZ. So CZ, CZ cancel. So wait a minute. I think I made a mistake here. AZ is equal to CA minus CZ plus A prime Z. A prime Z is equal to SCA plus, oh, sorry, left hand side only I made a mistake. Yes. SCA can be written as CS minus CA. SCA dash CS plus CA dash is equal to E into AZ. AZ is CA minus CZ. Then CA prime plus CZ. So this cancel. CA cancel. So CS is equal to 2A. 2CS is equal to 2A. So that means SC is AE comma 0. In ellipse also you got the same thing. Next one is, I don't want to turn the page. Here only I will write. What is the next one? SCA prime minus SA is equal to E into A prime Z minus AZ. This is CS minus CS plus CA prime minus CS minus of minus CA is equal to E times of A this one CZ minus CA plus CZ. So CZ is equal to A by E will come. So this is X is equal to A by E. What I'll do is so what will happen here? CZ is equal to A by E. So that means Z is A by E comma 0. Okay. Please copy this one. This is very similar to our ellipse, parabola, hyperbolas. In only parabola, this portion will not be there and this calculation will not come. Directly that is coming. Is completed? Okay. So now what happened? No, A is not the focus. S is the focus. A is the not the focus. S is the focus. So now continuation I'll be giving how this one has come. So now the theory part is over. And please understand whatever this one standard form of the equation is. Just a minute. Sir, today you will take only paper discussion. Why, Nana? Why? Paper discussion. Why do you want the paper discussion? I'll do that one. I have certain ideas, other ideas. Okay. Array, what A and A? Let me complete. No, I stop that one to copy. I'm going to tell you. Don't worry. Now, let us take that equation. So we got this one. Okay. Now, you have S here. You have A here. You have Z here. You have C is here. And here you have A prime. Yes, you got it as A comma 0. Sorry, AE comma 0. So what are the points we got in this one? S is AE comma 0. A is A comma 0. A prime is minus A comma 0. Z is A by E comma 0. So that means equation of directrix is parallel to y-axis and passing through this one. So x is equal to A by E. This is the directrix. And as usual, this is the y-axis. So now what I'm going to do is, I will take a variable point P. I will take a variable point P. Okay. Because now I got the directrix, I got the focus. I can write the equation. And by default, I took SA by AZ. SA by AZ is equal to E. So that means A is the point on the thing. And so you will be getting the equation like this. So don't assume this A. A is here only itself. Okay? Because so you proceed solving further. SP by PM is equal to E. SP square is equal to E square into PM square. So x minus AE whole square plus y square is equal to E square into x minus A by E whole square. Because one unit that. So from here you will be getting here important thing. You will be getting 1 minus E square into x square plus y square is equal to A square into 1 minus E square. This is what you got in the hyperbola also, ellipse also. After this, you wrote there x square by A square plus y square by A square into 1 minus E square. But here what I'm writing is, I'm writing minus y square by A square into E square minus 1 is equal to 1. Why I'll tell you. Since E is greater than 1, there exists B belongs to R such that B square is equal to A square into E square minus 1. So here what happened? A square plus B square is equal to A square is square. So that is what I told you. Whatever the property of ellipse, replace b square with, because only this difference. There we have taken b square is equal to a square into 1 minus a square. If you want, you cross-check, recheck that one. So there we have taken b square is equal to a square into 1 minus e square, because there e is less than 1. Here e is greater than 1. I have taken this. So this equation reduces to x square by a square minus y square by b square is equal to 1. Where e is equal to square root of a square plus b square by a square. Okay, now yes, Sai Charat.
Hello, sir. On the right hand side and left hand side, we are having 1 minus e square, no, sir. Then how it changed to e square minus 1, sir?
That's why I took minus sign here, no beta.
Okay, okay, sir.
Okay. So, Hemant,
Sir, as here B is greater than
be greater than?
B is greater than A, no, sir.
We don't know.
So that's why we got B square is equal to A square into E square minus 1, no, sir.
No. B here, B need not be greater than A, Nana. B need not be greater than A. Only E is greater than 1, only we know. Okay. Here, unlike a hyperbola ellipse, here A can be greater than B or B can be greater than A. There is no problem. Okay.
Okay, sir.
Yeah. Here only E greater than 1. So, here important point is, if alpha comma beta be a point on ellipse hyperbola, automatically plus or minus alpha plus or minus beta also point. So that means curve is symmetric about both x comma y axis. So due to this, we will get two sets of foci comma directrix. So that's why actually we got AE comma 0 focus, corresponding directrix is A by E comma, sorry, X is equal to A by E. So that means minus AE comma 0 is focus, and what is the next one? X is equal to minus A by E is the directrix. Okay, please take it. Please take it. Make it fast. So because of that, what you'll get? You will be getting a para curve. Actually, you'll be getting this one. It's not only because of the what you call this one. This curve is with respect to this focus and directrix also will come. Okay. So only difference is earlier vertex is between the center and the directrix. Okay. So at that time, previous ellipse, what is the thing? Ellipse used to be like this, and foci is internal and directrix are external. Now directrix are coming here, and this is going out. Okay. Yes, completed. Right. Right. So look at here. What we will do is now x square by a square minus y square by b square is equal to 1. X square by a square minus y square by b square is equal to 1. So x square by a square is equal to 1 plus y square by b square. So clearly x square is always greater than or equal to, this is greater than or equal to a square. So minus a less than x less than a, no curve. Okay, so that means here range is, what is the range? That means either x is less than or equal to minus a, or x is greater than or equal to a. Next one is, because this is a positive, otherwise you can take now y square by b square is equal to X square by A square minus. From here also X square range you will be getting. So y is nothing is there. There is no nothing is called what is the range of y we can able to do here. Next point is here A comma A dash is known as the axis. What type of axis? Again, in the earlier major axis and minor axis were there. So here what we call this one? This is called transverse axis. Okay. So what is this one here? A dash is transverse axis. So here what we will do is A dash is length of transverse axis. Length of transverse axis is equal to 2a. So here y-axis is known as the conjugate to axis. Conjugate to axis. So which is equal to length of conjugate to axis. It is a little confusing. Length of conjugate to axis is equal to 2b. How come 2b is coming? See, here, if I say this is the transverse axis, this length is 2a, that's everyone accept. But where is the 2b on this one? So, for that one, actually what we will write is, okay, y square by b square minus x square by a square is equal to 1 is called as conjugative hyperbola of x square by a square minus y square by b square is equal to 1. Means interchanging the transverse axis and the conjugate to axis. So what is the transverse axis of conjugate to hyperbola is the length of the conjugate to axis. Length of the conjugate to axis. Okay, so this is the conjugate to hyperbola, and conjugate to hyperbola, transverse axis, length of the transverse axis of conjugate to hyperbola is the length of the conjugate to axis of this equation. Leave that side directly. Whatever the positive term is, then x square by a square, that 2a is the length of the transverse axis, y square by b square, 2b is the length of the conjugate to axis. Okay, right. Now when you want to add, now what we will do, we will take, instead of taking this way, we will take x square by a square minus y square by b square is equal to minus 1 will do. In the later part, we are going to work on that one also. You keep aside. Okay, so now you got everything. Now you look at here. You got the equation. If this is the equation, how it will be, how this equation is going to be. This is the transverse axis for this hyperbola. This is the conjugate to axis. And x square, this equation is going to be like this. And this equation is going to be like this. Okay. So S dash, this is S 0 comma B, S dash 0 comma minus B, C, b dash is 0 comma minus b, b at 0 comma minus b, y is equal to b by e, y is equal to minus b by e. E square, e is equal to square root of b square plus a square by b square. Okay, so here bb dash is the transverse axis. bb dash is the transverse axis. Okay, please take it. So where you didn't understand this concept, simple. Here earlier x square by a square plus y square by b square is equal to 1, a greater than b. B greater than a, ellipse is coming this way. Here what happened? X square by a square minus y square by b square is equal to 1. You have the hyperbola like this. Now if the hyperbola is like this, okay, so here what happened? The transverse axis convert into conjugate axis convert into transverse. Conjugate axis is not intersecting the hyperbola at all. Like imaginary, this is. So this hyperbola is called conjugate to hyperbola. So what is this equation? Y square by b square minus x square by a square is equal to 1. Here a greater than b greater than a doesn't matter to at all. So here what happened? Foci will be on the y-axis, directrix parallel to x-axis, this one. Okay, eccentricity also b square root or b square plus a square by b square. Okay. Yes, Shiva.
Sir, in first case, can you explain the conjugate axis by showing?
Little louder, little louder.
So once can you explain the conjugate axis in first case, sir, by showing diagram?
Conjugate to axis. See, this is the transverse axis. The line perpendicular to the transverse axis is conjugate to axis through the center. Because the curve is symmetric about this axis of this line also. Okay. Is the curve is symmetric about this line? Yes. So what is that axis is called? Since it is not intersecting, we call it as the transfer, conjugate to axis.
Sir, how the length 2b, there is any derivation, sir?
That's what I gave, no? So conjugate to axis, length of the conjugate to axis is the length of the transverse axis of its conjugate to hyperbola. What is the conjugate to hyperbola of this one? Y square by b square minus x square by a square is equal to 1. So what is its transverse axis length? 2b. That is the conjugate to hyperbola, conjugate to axis length. Okay.
Okay, sir. Yes, sir, understood.
Yes, Sunat?
Without relation between A and B, like B greater than A or A greater
No, nothing.
than B.
No such relation. In the ellipse, why we are going with that one is E square is equal to A square minus B square is coming. So that's why you need to take whether A greater than B, B greater than. Here nothing is there. No relation between A and B. Okay. Except this one. Okay.
Then how can we like change it, sir? For what is the reason to change the axis, sir?
No, if such hyperbola, see types of hyperbola, this is the second type of hyperbola. Okay.
Okay, sir.
This is another. But what happened when we are going for the asymptotes, no, there is a relation between hyperbola and conjugate to hyperbola little. Okay. So when you
Okay.
add hyperbola and conjugate to hyperbola, no, you are going to get the pair of lines.
Okay, sir.
Okay.
So E is greater than 1, sir. With that
Yes.
relation also.
It's greater than 1 always. Yes, Satish. Satish. Satish, your mic is on. is completed? Right. Now, x minus alpha whole square by a square minus y minus beta whole square by b square is equal to 1. And next one is y minus beta whole square by a square, sorry, b square minus x minus alpha whole square by a square is equal to 1. So how these two are there? This is C. Hyperbola will be like this. So this point is A dash, yes, S dash, and the lines will be here, and the lines will be here. So here the lines are this one, and here it is like this. Hyperbola will be like this. Directrix is here. This one. B dash, C, Z dash, Z. Here also Z dash, Z. So you write here. Transverse axis. This is the transverse axis. What is that one? Okay, before that, let me start with. Okay, what are the things? You look at either side, you look at. Okay. Center. Okay, this space is sufficient. I'll start with here. I'll do one thing. This will be no problem. Center, this is alpha comma beta. Here also it is alpha comma beta. Eccentricity is this side, it is b square plus a square by b square. Here this side one, a square plus b square by a square, eccentricity. So I don't write is equal, because the moment I write is equal to, it will be. So I am writing the each part. Okay, next one. Transverse axis. For this one, transverse axis is x is equal to alpha. For this one, transverse axis is y is equal to beta. Conjugative axis. For this one, conjugative axis is x is equal to alpha. For this one, y is equal to beta. Vertex. Vertex here, b comma b prime. So which are, what is this one? Alpha comma beta plus or minus b. This side is a prime, which are alpha plus or minus a comma beta. Center already got it. Foci, S dash, alpha comma beta plus or minus b by e. Oh, b by e. No, be. I'm thinking the direct, writing the next one directrix actually. SS dash. Here SS dash, what will happen? Alpha plus or minus AE comma beta. Equation of directrix. Okay. Y is equal to beta plus or minus B by E. Here X is equal to alpha plus or minus A by E. Okay. Next, again, anyway you require length of lattice rectum. So I'm not defining again length of lattice rectum, etc. Why I'm not writing? That is the same definition only. Okay, 2b square. Oh, sorry. This side is 2a square by b. Here it is 2a square by b. Okay, please copy. Please copy. Yes, Hemant.
Sir, if A is equal to B, then the conjugate hyperbola and hyperbola will be equal, no, sir?
No,
Means,
no. X square minus a square is equal, x square minus y square is equal to a square, and y square minus x square is equal to a square. Both are not equal, no?
not the equation, sir. I mean, they both will intersect at 4 points, no, sir?
No, it will not intersect at 4 points. Actually, what happened, no? That is called the rectangular hyperbola. May not intersection is not possible because x square minus y square is equal to a square. Y square minus x square is equal to a square. So there is no intersection is not possible, Nana. Okay.
Okay, sir.
Sir, once tell TA, CA for the C. Here, if it is, look at here. This is the lattice rectum. If S is here, this is the lattice rectum. So at that time, this point is, this is SU take. So this is called the, whatever, this is the length of the lattice rectum. In this case, this is the lattice rectum. This is the lattice rectum. This is also lattice rectum. Okay. So the line perpendicular to the transverse axis and passing through the foci is known as the lattice rectum. Right. Completed? Now. We'll go further. Okay. See. Yes, Sunat? Yes.
Sir, in the last one, sir, the length of lattice rectum should be 2b square by a, sir.
What I've written?
You wrote 2a square by b only, sir, for both.
Oh, I wrote C.
Ah, yes, sir.
Just a minute. Oh, this side is 2b square by a.
Ah, yes, sir.
So all of you make a change that one. Now, what is the focal distance? What is the focal distance? This is the x-axis and this is the y-axis. So you have the directrix here and here the directrix, and equation of the parabola is here and equation of the parabola here. SC is here, S dash is here. You need to pair these two only and these two only. You cannot pair this focus with the directrix and this focus with this one. No. So if I take a point P, P is, let us say, x1, y1. Focal distance is SP is equal to E into PM. E into P. PM means this one. So E is equal to PM. You take this value minus, you take QM. QP minus QM, which is equal to E times of x1 minus A by E, because this distance A by E. So E is equal to EX1 minus A. Similarly, S dash P, same point on this one. So we need to take S dash P is equal to PM dash is equal to EM is equal to, look at here, QP plus QM dash, which is equal to E times of x1 plus A by E is equal to EX1. Okay, so EX1 plus A. So now what happened here? Modulus of SP minus S dash P is equal to 2A. Why modulus? I have taken P, so I'm getting the S dash P minus. So P can be this side also. So this is the another definition of the things. So here what happened? If A and B are two fixed points, A and B are two fixed points, P is a variable point. So you can write, if A comma B are two fixed points, A and B are two fixed points, and P is a variable point such that modulus of AP minus BP is equal to 2A, where here AB should be less than 2A. Because AB, the distance here, what is this one? AB should be 2A, so AB should be greater than 2A. AB should be greater than 2A. Then locus of P is hyperbola and A comma B are foci. Okay, so at that time AB is equal to AE will come and will continue. Okay, so in the ellipse case, sum of the distances. Okay, sum of the, please upload this Blackboard notes. Yeah, I see Blackboard when I'm teaching the theory, I'm uploading there in the OneNote, same OneNote only. Okay, so when I'm solving some questions and general things, I'm not uploading, but this one will be uploaded to the same file, but I'm going to name it as a hyperbola. Okay, right. So ellipse AP plus BP is equal constant and AB is less than 2A. Here AP minus BP is equal to A. So here what happened? No, if I take AP minus BP is equal to 2A, for example, in this case, what will happen? No, here A will be there, here B will be there. In this case, you are going to get this one as the locus. One arc of the thing will come. BP minus AP is equal to 2A if I take. If it is A, this is B, you are going to get this. Okay, so somewhere P will be there. AP minus B. Okay, yes. Yeah, yeah, let me write this one also. A is here, B is here. You can take this one, or you can take this one. Okay, so focal length and focal distance. Okay, Right. Completed copying. So now this is the basic theory related to the hyperbola. What is how the hyperbola is there, what are the types of equation, what is the focal length, etc. Now we are going to the analytical part, means all the questions and how the things are going to. So where we start with, as usual. Okay, let me give you the parametric form also, but actually parametric form supposed to be come after the auxiliary circle. Parametric form is supposed to come after the auxiliary circle. Okay, so since I haven't discussed the tangents, etc., I'm giving you the parametric form straight away. Okay, so look at here. What is the equation of the hyperbola? Equation of hyperbola is x square by a square minus y square by b square is equal to 1. So you look at here, x is equal to a cos theta and y is equal to b sin theta. No, sorry, I'm still in the ellipse mode. X is equal to a secant theta, y is equal to b tan theta. This is the parameter. You write any theta value. X square is equal to a square secant square theta, y is equal to b square tan square theta. So x square by a square minus y square by b square is equal to always 1. So you give any theta value. So this is the parametric form. So this is parametric equation. Parametric equation of hyperbola. What is that one? X by a, x is equal to a secant theta, y is equal to b tan theta. Okay. So now in the next step, I will write the notations. S is equal to x square by a square minus y square by b square minus 1 is equal to 0. What is S1? Xx1 by a square minus yy1 by b square minus 1 is equal to 0. It's a linear equation. S12 x1 x2 by a square minus y1 y2 by b square minus 1. Don't write is equal to 0 because it's a constant. We are not sure whether it is 0 or not. Next one, S11 x1 square by a square minus y1 square by b square minus 1. Here also it's a constant term. Here also it's a constant term. Now, chord joining px1 y1 y1 q x2 y2 is s1 plus s2 is equal to s12. Or chord joining why I'm writing join double. See, P alpha Q beta. What is P alpha Q beta? P alpha is A secant theta, B tan theta. This equation is x by A cos of alpha minus beta by 2 minus y by b sine of alpha plus beta by 2 is equal to cos of alpha plus beta by 2. Okay. Proofs are not required. If you want, you can try. Tangent at px1 y1 is, what is that? S1 is equal to 0. What is that? xx1 by a square plus yy1 by b square. No plus, minus, is equal to 1. Tangent at p alpha, p theta is x by a secant theta minus y by b tan theta is equal to 1. Because alpha is equal beta is equal theta. So x by a minus y by b sine theta is equal cos theta. So you'll be getting this one. So for these proofs, actually I'm not giving. Do you require proof? Then I'll give you. It's not really required because so many times we have done. If required, what happened? You differentiate and at x1, y1, you will be getting the slope of the tangent and passing through x1, y1, etc. You can write. But before that one point is missed out. The position of the point. That is very tricky thing. I'll explain. So please copy this one. Please copy this one. Yes, Satish. Satish, your mic is not proper and you are raising on. You just check. Yeah, please give the proof. Then only we do in advance. I know better. You for that doing advance, it is the proof is not required. You need to do only derivative of the curve and substitute line, find the line equation. Okay. And where is whichever the important for this model we completed for circle, ellipse, parabola. Okay. Yes, Satish. Satish, I gave you your mic. I gave the mic. It's still on. You just check and speak to me. Right. See, position of the point. Position of the point. This is the equation. Okay. This is the hyperbola. Like S is equal to x square by a square minus y square by b square minus 1 is equal to. So any point on this one x1, y1, clearly x1 square by a square minus y1 square by b square minus 1 is equal to 0. So that means here S11 is equal to 0. Now if I extend this one, and you will be writing here, for example, this is x2, x1, y1. This is like x1, y2. So clearly your y2 is greater than y1. So what is this? So if you write here x1 square by a square minus y2 square by b square minus 1, I'm subtracting more values. So this is will be less than 0. And if I take here x1, y3, for example, y3 is less than y1. So here what happened? x1 square by a square minus y3 square by b square is greater than 0. So the difference is, the compared to this one, S11 is equal 0, px1, y1 on the curve. S11 is less than 0. S11 less than 0. This is S11 less than 0 situation. But generally what happened, parabola, ellipse and hyperbola, a circle S11 to point lies inside. Here what happened? In between the curves. Because this is not the inside the region. This is not the inside the region. So you can say Px1, y1 between the curves. Between the curves. Frankly speaking, it is not exactly lies outside, but it is outside only. Okay, because for this curve, this is inside, this is inside. S11 greater than 0, Px1, y1 inside the curve. So this is the difference. Okay, so generally what happened here, from here you can draw two tangent, from here no tangent. That we are going to study later. So it is when comes to the things, because it is the parabola, what happened, this is like, so it is clearly inside, this is outside, we can say. But when it comes to the hyperbola, it is dividing into three regions. This is the region 1, this is the region 2, this is the region 3. So what happened, region 2, which is between the curves, we treat as the outside, and that is S11 negative. S11 is negative. Okay, yes. Now we explain in this one in diagram, so I'll explain now. Why so people, you people are so worried? Why can't you look at this one? What is that one? Yo, Rama. I'll explain. I'm giving the theory, just to hold on for some time. This is the curve. This is the curve. See, diagram is very bad. Wait. I'll explain, Nana. You first you copy this one. You copy this one. Okay? I'll give you the proofs also. Don't worry. I'll give you the proofs also. Right. So, yeah, quickly I'll talk about these tangents, normals, chord joining the things. Okay. So the curve is S is equal to x square by a square minus y square by b square is equal to 1. I require tangent at x1, y1. So 2x by a square minus 2y by b square into dy by dx is equal to 0. So dy by dx at x1, y1 is equal to b square x1 by a square y1. Yes. What is the tangent equation? Tangent equation is y minus y1 is equal to b square x1 by a square y1 into x minus x1. So from here, a square y1 into y minus y1 is equal to b square x1 into x minus x1. So from here, I'll divide with everything. So this is y1 minus y1 square by b square this side is equal to x1 minus x1 square by a square is this. So from here what you're going to get xx1 by a square minus yy1 by b square is equal to x1 square by a square minus y1 square by b square. But point x1, y1 on the curve. So x1 square by a square minus y1 square by b square is equal to 1. So from here you will be getting xx1 by a square minus yy1 by b square is equal to 1. Now here, if I substitute x1 comma y1 is equal parametric form, that is a secant theta b tan theta. If I substitute, you will be getting, what is that from here? X by a secant theta minus y by b tan theta is equal to 1. Okay? Please take it. Yes. Let us move to the next one. Oh, this has gone. Right. Look at you. Next one is the condition for tangents. What is the condition for tangency for ellipse? C square is equal to a square m square plus b square. Replace b square with minus b square. C square is equal to a square m square minus b square will come. Okay, so that is how we do. Condition for tangency. Now, y is equal to mx plus c is a tangent to hyperbola x square by a square minus y square by b square is equal to 1. So that we need to find. So what I'll do is, let y is equal to mx plus c touches hyperbola at px1y1. So that means tangent at px1y1 as per the theorem, what will be getting? Xx1 by a square minus yy1 by b square is equal to 1. So this equation and the given equation, what is our given equation? Minus mx plus y is equal to c. 1 should be equal to 2. Both are the tangents at the same point. So what you are going to get? x1 by a square by minus m is equal to minus y1 by b square by 1 is equal to 1 by c. So x1 y1 is equal to minus ma square by c comma minus b square by c is a point on x square by a square minus y square by b square is equal to 1. Their point of contact is minus ma square by c comma b square by c in the ellipse, but here it is in the reverse. So here what happened? X1 square, so that means you will be getting x1 square by a square minus y1 square by b square is equal to 1. So what you'll get? M square by a to the power of 4 by c square a square minus b to the power of 4 by c square b square is equal to 1. So that means m square a square minus b square is equal to c square. So what is the condition? C square is equal to a square m square minus b square. What is the point of contact? You take this one. Okay. So point of contact is minus ma square by, means actually you can plus or minus ma square by root over a square m square minus b square plus or minus b square by root over a square m square minus b square. Actually what happened? No, there is a scope for this value goes to 0. Because in the previous ellipse case, a square m square plus b square cannot be 0. But here a square m square plus b minus b square is equal to 0. There is a possibility of this is going to 0. When it is going to 0, the resultant equation is called asymptote. Tangents which touches at the point of infinity. That is not exactly in this week's syllabus. So, but anyway, in the later part I'm going to cover because I'm decided to complete the hyperbola in this week. So I'll continue that one because if I go with asymptotes, completely deviation. I don't want to touch that one. If per minute. So this is the point of contact. Now here only you write, if the line is Lx plus my plus n is equal to 0 is a tangent, then what is happened? No? A square L square minus B square M square is equal to N square. How do you get this one? This equation 1 and this one you compare. What will happen? This is the 3. So 1 is equal to 3. X1 by A square L is equal to minus Y1 by B square M is equal to, here 1 is that side, here minus N is this side. N is, so what you are going to get, point of contact also, minus A square L by N comma B square M by N. You substitute this equation, you will be getting, this is a condition and this is the point of contact. Okay, please take this one. Maybe you feel that I'm going little fast. No, it's I'm not going little fast, but these are all known to you actually. Okay, so everything, only the equation form is changing. Equation form only changing. So generally, if you are there in the physical class, no, I would have completed this one introduction only completely, and I ask you to make the problem, solving the problem straight away. Yes. So just here number of tangents etc. we'll study tomorrow, because that will be too much. Now whatever I covered, I'm going to upload to the OneNote. Okay.